Hi, Elasticians. We're back.
Howdy, y'all. So today we're going to talk about fixing shards that have grown too large. So, and if we can undersize your shards, the Elasticsearch documentation ends up recommending that shards can size between 10 and 50 gigabytes for optimal performance. So if you end up going above this, you may end up noticing one, uneven disk sizes, just because that shard is growing large enough to potentially be a significant portion of disk. Two, you can end up noticing ingest issues or delays, where the reason for that is that an index refresh is taking effect on a shard. As that shard grows larger, that process is taking longer. Three, directly related to that, search performance for that shard may end up growing a lot more intense. Four, you may end up noticing as the cluster is trying to migrate data either across data tiers or in order to balance shards, that shard recovery process ends up taking a lot longer. And that just directly speaks towards the size of that shard. So again, it's not a hard limit, but it is an Elasticsearch recommendation that we keep shards 50 gigabytes or smaller.
Well, I think it's important to talk about our shards and the fact that they're leucine indexes. And so each time those run, it's running its own little process. And so it's taking up resources. So sharding responsibly is super important for the happiness and health of your cluster and your mental health. Is that
Amen.
on topic?
Yeah, I love it.
It's like one of my favorite things that I like to quote about what I've learned about Elastic so far, because I just think of like little workers, like coming up out of like little ants. Anyway, continue.
Yeah, dude, I highly agree. Especially where shards are where software meets hardware, right? We effectively in that firmware ballpark are starting to deal with problems both sides, and it's just what keeps that joint functionality working well together. So, highly agree. I appreciate the call out. So, for our purposes today, we're not going to induce 50 gigabytes. We're just going to show you an example setup where potentially we could induce the issue. So starting with this doc example here where it says cat shards, like my data stream has hit 50 gigabytes. Um, Usually what Elastic recommends, which you can see on like the paragraph before, is that when you're using ILM, that you set the ILM rollover to have a max primary shard size of 50 gigabytes. That's induced by default now, and the reason for that is just to protect your cluster overall performance. So if you don't have that, wherever you're missing it, we recommend setting it. But the reason for that is, let's hypothetically say that data stream instead didn't say 50 gigabytes. It said an individual shard was 100 gigabytes, multiple hundreds of gigabytes, multiple terabytes. This last week, I got to deal with a 3 terabyte, and that's an intense party by the time shards grow that large. So, when this ends up inducing, you have two major ways to recover. Uh, Basically, for the shards that are affected, you're going to want to split that index up into more shards. So how you split that up is either literally using the split index API, which increases the number of primary shards, or alternatively, you use the reindex API. The reindex API can be helpful when you need to change other settings and or mappings at the same time. Um, Between the two of them, basically the same thing. Elastic support side, we don't really make a differentiation. In my experience, users frequently go and run the reindex. I think that's just happenstance, right? Like, I really don't think it matters between the two, which you do. But because of Stephanie's hearsay, we're going to end up running the reindex today. Um, yeah. Okay, so do you mind showing the next tab? So we're just going to do a quick setup. So the ILM tutorial for setting up a data stream, we're going to be running through these steps. We're going to critically miss on step 2, you're supposed to associate an ILM policy. We're going to miss that. So this is how we're going to end up showing the issue so that we can try to recover the issue. So
Great.
glorious Annie, set up a deployment for us.
Too much data.
Yeah, yeah.
TMD. You know, that was the first question on everyone's mind. What is the acronym? Acronym? Mim.
Yes. To be fair, I thought I was so funny, but you know, when you're like too pleased with your own joke. Yeah.
I laugh at myself all day, and the room will be silent. So,
I love
anyway,
it.
so showing this is an Elastic Cloud because we are focused on Elastic Cloud in these videos, which is great.
Yeah. So it's a basic deployment setup, all of the defaults out of the gate. So for our purposes, if we can jump over into Kibana, we're going to go directly to DevTools, pre-populated some commands. So the data stream we're going to be working on today is going to be called pandas because that's cute.
Okay, so let's go ahead and start making our pandas data stream. Bum, 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 bum.
Yeah.
Okay, I'm gonna go ahead. Okay, acknowledge true.
Okay, so ILM policy does have Elastic's default recommendation of having max primary shard size cap at 50 gigabytes. So that part's happy. That's exactly what we want it to do. The next line down, though, contrary to that setup doc, we are going to miss setting that ILM policy to affect our index, which is that.
Really sad. Okay,
Awesome.
that our index template. We're going to create a pandas doc. You have to believe in yourself. That's so cute.
Yeah.
Okay, it was successful.
Yep. So creating a doc because of that template automatically gave us the data stream. So now we can go run an ILM explain against that data stream name. And yeah, if you'll hit play, it's gonna, oh, it
Okay.
did hit play. Okay. Line 3 tells us the automatically created backing index. Can we grab that index name? We're gonna need it here in a bit, including the dot. Yeah. But
Oh,
highlighting for
oh,
folks, we did not expect line 5 that it says managed faults. That would by itself be the symptom that you would notice live in production that something before now didn't go your way.
and let's put a pin in that because that's really important. And I think that's actually a very common miss, especially when you're not regularly managing this stuff. Everything looks like it created, and it just flies right over our heads.
Yeah. I mean, it all created, it just didn't associate. So we were at the finish line and walked away, I guess. I don't know what that metaphor is.
I don't know if I've heard a metaphor like that, but slow and
Yeah.
steady wins the race, I think. And
Yeah.
we weren't slow and steady. Okay,
That's
I
okay.
think we're not missing the mark. Okay, so let's go ahead.
Before
Cut.
you lose that copy, line 25, do you mind just hitting enter and as a comment writing our index name?
Yeah, I can't find my.
No, you're good. Sorry. Farther down, we have placeholders that we're going to have to fill in. Okay, so highly agreed. We're ready to run line 29.
Okay, so here we see we have a replica and primary shard. 4.
Yep. And both of these store sizes are only 5.1 kilobytes, as Annie's highlighting. So for our purposes, we're just going to say hypothetically, like that doc before, let's say the store size right now was showing hundreds of gigabytes or multiple terabytes, right? For our purposes, I'm not creating 50 gigabytes to just try to show you. We're just going to pretend. So let's pretend it shows 5 terabytes. Yikes, right?
They're huge.
We should fix that. That's crazy.
Or else everything's going to go awry. Our performance will suck. We won't be able to query things efficiently. It's just going to be awful. Ingest could completely halt. We simply
Yes.
cannot by this.
Also, 5 terabytes is potentially literally disk size, so we may literally be hitting flood stage right now.
We've done so much in this shit. I'm stressed.
I'm glad it's hypothetical.
I do.
Cool. Okay, so resolving this situation is going to come down to two separate steps, right? The first one is fixing going forward. So earlier, because the index template is handling that index creation, all we have to do is actually include that line that we accidentally missed. Yeah, do you mind running that? And then on line 45, we can now port ingest into that by forcing a rollover on our current index. So new ingest is going to start pointing to that other index. And then the only thing remaining affected is both of those indices, the fixed ones being ingested into, but both are potentially being searched. So where search performance issues are ongoing, we still need to fix our historical. What's
Yes.
up, Annie?
Um, I know that doing a rollover can feel intimidating, but it is generally safe if you set everything up correctly. So
Yeah.
feel confident in your rollovers.
Yeah.
I'm gonna,
Also, if anything was going to go astray, it would have errored on us. That's not common with data streams. That's common if you set up your own alias, and those errors are pretty well documented on what to do. And also, we've recorded videos on how to solve them too. So if you erred on that rollover step, you're good. Go check one of the videos related to fixing it. Okay, so if we run the next line, so we're going to now show that we have two indices. Yeah, will you
I'm
run that
sorry.
line? No, you're good. Line 47, will you run line 47? Perfect. Cool.
Uh,
So we, on line 2, have our original index. It doesn't have ILM associated, but line 24, our second index, line 27 has ILM associated. So this is how we know and can confirm that going forward, we're not going to encounter a problem again. That ILM policy that says max out at 50 gigabytes is going to take effect on line 2, and via the index template is going to apply into the future for all future rollovers. So congrats, we have solved it. Yay.
yeah. Okay. So now we have to go and address the historical trouble, which I feel like is always what haunts us the most.
Yeah. It's called
Um,
technical debt, you know. Wah, wah.
and I don't know a single person whose favorite topic is technical debt, but that's okay because we're going to try and help solve just a little bit of what
Yeah,
happens with that. Um, just highlighting this will be the backing index that we're focused on.
yeah. Do you mind, while we're in this pause, copying that index either from right there or where we had it on the left-hand side? Line 50 and down has that as a placeholder. So anywhere it says my first panda's index name in all caps, we can just swap out that placeholder now that we finally have it.
Okay, I'm just going to my first pen.
Awesome. And then for everybody at home, um, so that size your shards documentation ended up claiming that we would go line 70 as well, that we would go follow the reindex documentation. So the steps that we're about to talk through right now are the steps that that reindex documentation ended up highlighting. Do you mind showing tab to the right, the actual reindex API documentation? So this is what it links to. We are just following defaults because defaults work for our purposes. But if you mind scrolling down, so like the right block and everything is prerequisites. So make sure to read through. It recommends creating the destination first. It recommends setting a write block. And then under description, any of the settings that you need and want to set, it nicely kind of outlines like for your specific use case, what to go check so that you end up setting what you want. Again, ours isn't test examples, so we're just going to use defaults.
Okay, so we're going back to
To
DevTools. We're in DevTools. So now we're going to go to resolve historical. So the first thing, I'm sorry, I just hijacked this and started just chatting. Um,
I like it.
the first thing from the prerequisites discusses setting a write block. So we're going to go ahead and set a write block on this index so data's not writing to it.
Yep. So I think as everybody expects, because we rolled over the data stream, we're effectively just expecting this to be like a baby admin test that has no impact. Technically, data streams can receive updates, so technically you have to set it, but it kind of feels a little no-oppy, which is fine, right? So it now has a write block set against it. Same as the documentation said, we're going to go create our destination index. For our purposes, I don't really care what it's called, so we're going to call it reindex pandas. Highlighting, at this point, you'd potentially have to do the math. So we said the shards are at 5 terabytes. If we wanted to get those down to 5 gigabytes, you, at the end of line 55, number of shards, would be doing that math to figure out what number of shards to set, and it would be pretty high. Again, for our test example, we're just showing the shift. So we're going from 1 shard up to 2 shards.
Okay. So
Yep, so we're going to create our destination. It's going to be such a pretty destination. Yeah. And then afterwards, we can click to reindex.
no oppie is so funny.
That's fair. I was trying to figure out how else to say it, and it was like, you know.
So one really important thing, and we'll talk about this in a minute, but just because we re-index to the new index does not mean there's an automatic deleted 0. Sometimes I think that pops up periodically where people don't realize that immediately.
Yeah,
Anyway,
that's
okay.
that's an excellent call out. So the reindex task, the reindex API is going to kick off an asynchronous task. For our purposes, our index is only the size of 1, so we're not going to catch that task. It'll be way too fast. If you did have 5 terabytes, you're going to have to watch list tasks in order to see that process complete. As Annie just highlighted, when you are performing the reindex command, you have the opportunity to run sub filters, right? Like effectively like an update by query or delete by query or a painless script. In those circumstances, you could have expected deleted docs. For our purposes, we're literally just copying, so we're not going to have any deleted docs. But also, it was only 1 doc, so our asynchronous task was almost as effective as that API, straight up. So line 62, let's just refresh to make sure everything's through there. I talked long enough, it probably auto refreshed by itself. And then line 64, let's confirm our source and destination end up with the same number of docs. Docs count 1. Yay! Okay.
One and a perfect migration.
Yay! I'll call it a migration with you. That's chill.
Thank
Okay.
you. So
So
once we've confirmed everything is there, I don't know why I did that.
go for it.
We can delete. I love deleting things.
Yep.
We're, of course. So we're going to delete the original index.
Yep. So at this point, we had that data twice in our cluster, where one of them is fixed for future search performance and the second one is not. Once we confirm that all of the data in the destination is as we expect, we deleted the first. The reason for this is that it frees up that logical space so that we can now add an alias that points our re-indexed index back to the previous name so that anything client side doesn't have to account for the change we just made inside of the database.
Great.
Yes. So if you'll hit
Okay.
play on that, this now means that the cluster we fixed going forward and we just fixed historical. So all ingest and searches now are working on appropriately sized shards and are going to be a lot more performant. So at that point, the cluster is fixed. There is one last step though that we're going to end up encountering, and that's because of the manual work that we did on our index that we created on line 54, we did not set a rollover alias because it should not roll over. So awesome. So this one ends up telling you there's a rollover alias error because we didn't set the rollover alias, because we don't need this one to have a rollover alias, because we fixed going forward. So for our purposes, that error normally is unexpected. For our purposes, that error is expected. So because of that, line 74, we're going to say the rest of the ILM policy is good to continue applying to that index. We just needed to like move it to the side, and then afterwards, what this next step is going to do is it's going to say, you were waiting to roll over. I don't need you to roll over. So do the step after rollover, which is just sit in hot complete complete until the rest of the ILM policy is able to continue. I think Annie's already highlighting, which is excellent. Line 15, the check rollover ready step is going to auto retry. So sometimes the step will be error and sometimes the step will be check rollover ready. Our line 78 needs to match whatever the step currently reports. So for our purposes, I wrote check rollover ready, but right now it says error in all caps. So we're going to write error in all caps and then hit play. Awesome. And then we can run ILM explain against it again. And now it's going to tell us it's in hot complete complete. So at that
Yay!
point, we are golden. Yeah.
Amazing.
Yeah. Is fabulous. Me gusta. Okay, so throughout this video, we ended up demonstrating a common reason you can end up with shards that are too large is by missing setting ILM or by setting up ILM rollover incorrectly. Resolving ILM is covered in other videos, but two, if you found yourself in that situation, we just covered the most common way to resolve those shards that are too large, which is by doing a reindex to the appropriate number of primary shards.
Great. Super exciting. I'm so glad we did this video.
Yeah. I'm glad that people can like kind of see it live so they can get the flow because it is a lot of API commands.
It's a lot of API commands. It also it's very layered, and I
Mm,
can see how it would be confusing to try and involve everything and make sure everything's set. So I'm excited about this one.
yeah. Cool. Awesome. Well, thanks everybody and thanks Annie for joining me.
Thanks so much.
Cool. Bye.
Bye.